Hello friends, in this lecture we will see contour area or area mill. First delete this and click here and come to this mill contour, and here in mill contour we have this contour area. Contour area is a fixed axis surface contouring operation where we can create this operation on the selected surface. This operation is especially used for finishing operation, and here we can also define all the surfaces in steep or non-steep areas, and we can also define the angle between steep and non-steep area. Like if we want to define steep area between 90 to 60, we can enter 60. If we define non-steep area with the help of angle, so we can also change the angle. Here you can see this is steep area, this is non-steep area. Here this is steep area, the non-steep area, and the tool path will also generate for steep and non-steep separately. We can also define the cut pattern separately or different the cut pattern in steep or non-steep area. So the workpiece is already defined. If you want to define, just click here, and the part, click here, and it is bounding block. So I am using offset from part and use 0.01, right? Units are in inches. Okay, okay, and the tool is this one, the ball mill tool I am going to use. Click here and select the contour area for finishing. Now define the program location in program folder. A tool is this ball mill and the workpiece, and the operation will be finished. Okay, so I am assuming all the roughing, semi-finish, arrest milling operation have been done. Now I am just doing the finishing operation. So the best part of this area, contour area, is you can specify the selected area where you want to define tool path. Select it. Now first come to geometry and select the specific cutting area. So here I just want to create tool path for this selected area. Okay, come to this main, and here we have steep. Now the steep area is between 90 to 60 degree, and these parameters are for steep area. Let's generate, then we will make some suitable change. Say this is the steep area, so the tool path is generated only for the steep. Here if you want to increase or decrease depth per cut, merge area, minimum length, so we can also define. The merge distance is 50%, so I am going to increase it 400. Let's see, this area may be merged. See here it is merging not properly because of shape. We have used offset from part blank type, that's why, right? So come to this 10. Here we are using zig. You can also use this zigzag, and see this. Okay, if I want to use for non-steep, the angle is still same. I am using follow parapary, and the step over is 10%, and okay. Now the cut pattern is follow parapary. If you want to change, you can also change with zigzag, and see, right? Now I want to cut both steep and non-steep, so select this. First we have this non-steep parameter. Second, path smoothing, switch on this. Second is steep areas, and in order steep area will cut first, then non-steep area will cut. Generate. Click here and verify. Steep area first, now non-steep area. Some area is still remain because of bigger tool. We have separate operation for this corner area. Okay. Now come to this geometry, and here if you want to define trim boundary, so we can also define trim boundary. But here we have one cut region option. Click this. In cut region, we can create different region according to our selected surface. Click here. Now we have two region. One is this one, the steep one. The second is this non-steep area, right? If you want to deselect any one, this is the inactive area. If you will generate again, only the toolpath will generate for steep area. Click here and select it. Okay. And if you will see, we have divide option. So I want to divide this toolpath with respect to plane. So select this face and a little bit lower, right? Now okay, and see this upper area and lower area both are separate, and now we have 1 2 3, we have 3 areas. And here you can see the first area is this one. It means the tool will cut this area first, then second is this one, then tool will cut this one. Now I want to reorder it, so drag and drop. So now the second one is the first, then second this, and then third is non-steep. Let's okay and generate it, and you will see the tool path. Verify it. Tool path will start from top. Okay. Okay, come to this. Again, now I want to merge these two toolpaths. I don't want to divide. You can reset it, okay, or we have this merge option. Click this merge. I want to merge this and this, okay, and see one reason and second reason. If you want to delete, you can delete it from here. Delete. Now, if you think that you have done something wrong, so you want to reset all, so just delete this one and click here to generate reason list again and okay. So in this way we can also create reason and we can cut with the help of selected surface. So hope you understand this, and I will share this file with you so that you can practice it. If you find the course is useful for you, so please rate our course positively. Thank you for watching. Hello friends, today we will see contour area or area milling operation from this mill contour. So one example we have already seen. This is the second lecture on contour area. So this is a fixed axis operation for finishing. So I'm going to select a ball mill tool, and I'm not using workpiece. I'm just making this operation under this MCS. So replay will generate, 3D area verification will not work. So no problem. See here we have steep and non-steep, and the steep area, this steep angle is 60 degree. Follow parapary and come to this and select the area. So my area is, I want to cut this area. Again come to this main, here generate. Part geometry is still not defined, so click here, and this is the part 1. Generate, and we will find this result. Here the steep is jig. I am using zigzag for steep. So steep area is this one. And for non-steep, I am again using zigzag and verify. Say this. So this kind of toolpath we have. If you want to verify, you can replay it. 3D verification cannot be possible. It will ask you for the blank, right? So we don't have any blank. Or if you want to define, go to this part offset and define this. And okay, it depend upon the dimensions are in millimeter or mm. See, we have inches dimension, so that's why it is too big. Again, click here and first see the replay. See, the toolpath is working like this. Okay, for 3D verification, click here and again it will ask you for the part stock. Now see, this is the non-steep area. In second case, I just want to remove the material from this non-steep area. Then again select it and come to this area, contour area. All the options are remain same. Click here and this time come to this geometry, select the workpiece and cut area. I'm selecting all the cutting area, but I just want to cut non-steep and generate. Toolpath will generate for non-steep. Click here and here we have zigzag. Select this zigzag and verify. If you will see, the toolpath is uh, working along the larger edge. So here we have cut angle. If you want to define, you can define with the help of vector. So toolpath will generate in this direction. Click here and the next is specify. I want to specify this with 45 degree. Now the toolpath will come at 45 degree. Okay, so here we have some different type of cut pattern. So hope you understand this. Thank you for watching. Have a nice day. Hello friends, this is the third lecture on area milling. So switch to manufacturing and here I have a part and one curve. So I want to use this curve as a limit, as a boundary, right? So here we have one part and one tool. This is the ball mill tool. Click here, 8 mm tool. So I will work with this tool. Click here and select the contour area. Okay, this is a finishing operation. Come to this geometry and select the solid geometry and cutting area. My cutting area is tangential face. Okay, and come to this main and under this main I just want to use non-steep and generate. Okay, and increase this step over so that it will visible properly. Sometime what happen, it will not generate proper tool path, so we can also increase or decrease this steep angle. Now the steep angle is 45 degree. See, the tool path is generate only for the 0 to 45 degree, the faces which are under the 0 to 45 degree. These are the faces for non-steep. And enter this value 90. This is the maximum value. Now the toolpath will generate from 0 to 90 degree, between 90 degree. If it is 90 degree, that time it is steep. Otherwise 89 to 0, it is non-steep. Okay, so this is the reason. And now I want to trim this area, so come to this geometry, and here we will find this specified trim geometry, and my geometry is a curve. Select the connected curve, and these are the curve. Okay, generate, and toolpath will generate. Okay, if I want to reverse this toolpath, means I just want to cut inside this area, outside area will be removed. So click this and keep outside, trim outside. So it will trim and generate. The toolpath will generate under this curve only. So hope you understand this. Thank you for watching. Have a nice day. Hello friends, in this lecture we will see area milling with spiral cut pattern. So first of all, I am going to define my part. So here is the part. Select this part. Blank I am not going to define. I am just showing you the tool path. So click this, and for tool I am using this tool. Okay, this tool I am going to use. Click here, and the method is contour area for finishing. Okay, here come to this geometry and select the geometry to be cut. Click right this inner area I want to cut, and come to this main, and for this steep and non-steep I just want to use spiral. Invert and generate. Say this, and come to geometry. Let's check it first. Say this. Okay, it is not proper, so I can change it inward to outward. Now generate. From inward it will start. Come to geometry, and here click this, and we have two areas. Now click first and merge with second, and OK, and see we have only single region. Now verify, generate. Helical spiral, we have Z level. Helical, we can also use this one, because after joining it is not working. So come to geometry and delete this. Okay, area is already selected. Generate it now. Now it is okay. It is spiral, and on vertical side it is helical. So hope you understand this. How to make spiral? We use for cylindrical, spherical, or this kind of closed area. We can use this spiral pattern under this area contour. Hope you understand. Thank you for watching.